The James Webb Space Telescope has captured images that leave even top scientists puzzled.
The cosmos holds countless mysteries, but few compare to the recent revelations from the James Webb Space Telescope concerning 3I Atlas.
It raises the question of whether this is a typical comet, a natural object, or maybe something technological.
This interstellar traveler, a true anomaly, has now unveiled a shocking truth about its very nature. We're talking about a chemical makeup so profoundly unexpected that it forces astronomers to rethink the conditions under which planets and comets form across the galaxy. This isn't just an interesting find, it's a cosmic bombshell. The more we learn about 3I Atlas, the clearer it becomes that what they found is truly worse than we thought. A Rosetta Stone from beyond. To grasp the magnitude of this, let's consider what this means. Comets are often described as cosmic time capsules, preserving the pristine materials from the early days of their parent star system. They are frozen relics, tiny laboratories floating through space. If 3I Atlas formed in another star system, its bizarre CO2-rich nature tells us something fundamental and perhaps unsettling about that distant stellar nursery. It challenges our understanding of how star systems and their planetary building blocks come into being across the universe. The mass loss rate from 3I Atlas is truly mind-boggling, with 129 kilograms of carbon dioxide being shed every second. To put that into perspective, that's roughly the weight of a large motorcycle being turned into gas every single second. That's nearly 285 pounds of CO2 vaporizing into the void, a constant stream from an object potentially only a few miles wide. The sheer volume of this outgassing is a wow factor that makes you reconsider the scale of activity happening on this relatively small, icy traveler. What many overlooked is the low abundance of water vapor. While carbon dioxide streams out, water, the universal solvent and a key ingredient for life as we know it, is surprisingly scarce. This low water content, just 5% of the CO2 output, hints at an internal structure that might be inhibiting heat from reaching its icy core, suppressing water sublimation. This means the comet isn't just different. It's weird in a way that suggests unique internal processes, or an origin in an incredibly cold, dark corner of another stellar system where water froze deeper or evaporated long ago. The implications are profound, suggesting interstellar objects might not be uniform, but rather a diverse collection of relics, each with its own alien story encoded in its icy heart. The most shocking fact is that initial size estimates varied wildly, from around 7 miles wide to a maximum of 3.5 miles, making it potentially the largest interstellar object yet seen. This behemoth is shedding carbon dioxide at an astonishing rate. This isn't just an academic curiosity. Every interstellar comet is a messenger, a tiny probe delivering its home system's secrets. 3I Atlas, with its unprecedented CO2 to water ratio, tells us that the universe is far more varied in its chemical foundations than our solar system alone could ever suggest. It forces us to ask, are there other interstellar objects out there with even more extreme compositions, waiting to be discovered? Its very existence hints at a cosmic history far more complex and violent than we once imagined. A galactic nomad. This cosmic wanderer, 3I Atlas, isn't just strange in its makeup. Its journey is equally bewildering. You see, this object is hurtling through our solar system at speeds that truly boggle the mind. It entered at 61 kilometers per second, or about 140,000 miles per hour relative to the Sun. This velocity isn't just fast, it's an indicator of its interstellar nature, moving far too quickly to be gravitationally bound to any single star. It's like a bullet fired from a distant gun, traversing the cosmic landscape for untold eons. Its orbital eccentricity, a measure of how stretched its path is an astonishing 6.141. To put that in perspective, objects bound to our Sun, like Earth or Halley's Comet, have an eccentricity less than 1. A perfect circle is 0. A long, stretched-out oval might be 0.9. An object with an eccentricity of exactly 1 is on an escape path, never to return. So, a value of 6.141 is almost absurd. It means its path through our solar system is for all intents and purposes a straight line, It barely even curves as it passes our massive sun. This number is the highest eccentricity ever recorded for an interstellar object, making it the most confirmed outsider we've ever seen. This incredible speed and trajectory tell us something profound about its age and origins. Scientists have suggested that 3I Atlas could be the oldest comet ever seen, potentially billions of years older than our own 4.6 billion-year-old solar system. Some estimates place its age at 7 or even 8 billion years old. This is truly a wow factor that rewrites our understanding of cosmic timelines. Its breathtaking speed isn't just random. It's evidence that it's been on the move for countless ages, gaining momentum from gravitational slingshots as it whipped past stars and nebulas in its home galaxy. Researchers hypothesize it originates from the thick disk of the Milky Way, an ancient region of our galaxy far older than the thin disk where our sun was born. The thick disk is a puffier, more spread-out collection of stars that formed in the galaxy's youth, a time of cosmic chaos and frequent star formation. This ancient provenance, combined with its unique chemistry, paints a picture of a universe where cosmic relics from entirely different epochs and environments can traverse vast distances and briefly visit our corner of space. The thing nobody tells you is how challenging it is to even observe such a fast-moving, distant object. The James Webb Space Telescope had to precisely target its very small field of view to capture 3I Atlas. It's like trying to photograph a specific fly from a mile away while both you and the fly are moving at high speeds. What many overlooked is that other telescopes, like the Hubble Space Telescope and the Sphere-X Observatory, also observed 3I Atlas. Hubble, for instance, captured a teardrop-shaped cocoon of dust coming off its solid, icy nucleus. This wasn't a normal, symmetric coma. It was lopsided, hinting at an uneven outgassing process. These combined observations are crucial, giving us a more complete picture of this enigmatic visitor. The fact that multiple powerful observatories are scrambling to study it underscores its importance. It's a once-in-a-lifetime opportunity, and you can see this everywhere. Scientists are keen to study its makeup before it whizzes past our sun in late October 2025. Making its closest approach at 1.36 astronomical units, about 126 million miles, between the orbits of Earth and Mars. After that, it will slingshot around the sun and depart our solar system for good, returning to the vast interstellar emptiness. This fleeting window emphasizes the urgency of gathering every piece of data possible. The clues it leaves behind are our only connection to its distant, mysterious home. So, while 3I Atlas poses no threat to Earth, its existence, its journey, and its unprecedented composition fundamentally challenge our cozy assumptions about the cosmos. It's a reminder that we are just one small island in a vast, ancient, and incredibly diverse galactic ocean. What else could these ancient travelers be carrying across the stars? A universe of unknowns. The discoveries about 3I Atlas, particularly its unique chemistry and extreme age, force us to look beyond the familiar boundaries of our own solar system. This interstellar invader isn't just a curiosity, it's a profound challenge to our cosmic models. Many people are crazy about the idea of life beyond Earth, and while 3I Atlas doesn't directly confirm it, its unusual nature opens up intriguing possibilities for how organic materials and even life itself might travel through the galaxy. To put it mildly, the very idea of a comet with such an alien composition raises a crucial question. Are these interstellar objects merely random debris, or could they play a more active role in seeding young planetary systems? Recent scientific discussions, some still speculative, propose that interstellar objects like 3I Atlas could act as seeds for exoplanet growth around young stars. Imagine millions of these interstellar bodies being captured by planet-forming disks, jump-starting the formation process, especially around higher-mass stars. This is a wow factor that connects our alien visitor to the grand narrative of planet formation across the universe. If true, then objects like 3I Atlas are not just passing through, they are active agents in the ongoing creation of new worlds. This idea, currently being explored by researchers, suggests that the universe recycles its building blocks in ways we are only just beginning to comprehend. The thing nobody tells you is that this could solve another long-standing mystery: why some planetary systems form so quickly. they might not be starting from scratch, but getting a delivery of pre-made ingredients from visitors like this one. The sheer speed and age of 3I Atlas imply it has been adrift for immense periods, a testament to the endurance of these frozen relics. This endurance suggests that if such objects contained robust organic molecules, or even dormant microbial life, they could theoretically survive such journeys. This concept, known as panspermia, is often debated, but findings like 3I Atlas, with its resilient, deeply frozen components, add another layer to the discussion. While no direct evidence of life has been found on 3I Atlas, its peculiar composition and journey make it a compelling subject for such discussions. The most shocking fact is that its trajectory is largely aligned with our solar system's orbital plane, or the ecliptic, meaning it's not coming in at a wild perpendicular angle. It's almost as if it's following a cosmic highway. Most interstellar objects should by chance come from random directions. The fact that it's playing by the rules of our solar system's orientation is statistically unlikely, and it has some scientists quietly wondering if there's a reason for that. What many overlooked is that some initial, controversial preprint studies even explored the idea that 3I Atlas could be a piece of possibly hostile extraterrestrial technology in disguise. These theories suggested that its unusual brightness and outgassing could be artificial. While mainstream experts quickly debunked these claims as nonsense, the fact that such ideas even arise speaks to the profound mystery these objects represent. This shows how desperate we are to understand what these cosmic messengers truly are. It highlights the vast unknowns that still permeate our understanding of interstellar space and the objects that traverse it. The high CO2 content could, in a highly speculative sense, be viewed as an exhaust byproduct from some long-dead alien probe, still venting residual gases after billions of years. Again, this is not science, but it's the kind of what-if that an object this strange naturally inspires. So, while 3I Atlas will soon leave our solar system, its legacy will continue to resonate, fueling research into the origins of stars, planets, and perhaps even life itself. It has opened a door to a universe that is not only larger, but fundamentally stranger than we ever imagined. But what if 3I Atlas is just the tip of a cosmic iceberg, our place in the cosmos? Now, let's talk about the real worry, the underlying anxiety that these James Webb discoveries about 3I Atlas bring to light. It's not about immediate danger. Remember, 3I Atlas will pass at a safe distance of 1.8 astronomical units, or about 170 million miles from Earth. The concern, you see, is far more existential. What they found, which is worse than we thought, isn't a direct threat, but rather a profound unsettling of our scientific foundations. It challenges the uniformity of the universe we once assumed. It implies that the cosmic building blocks, the very ingredients for planets and perhaps life, might vary wildly from star system to star system. This makes our quest to understand the universe far more complex and unpredictable. For centuries, science has operated under the assumption that the laws of physics and chemistry are the same everywhere. While that's likely true, 3I Atlas suggests the starting conditions are not, and that changes everything. Many people are crazy about simple answers, but space is rarely simple. The discovery of such an intrinsically CO2-rich nucleus, coupled with a lack of water, suggests that the conditions in its parent star system were dramatically different from our own. Perhaps the carbon dioxide ice line, the region around a young star where CO2 freezes, was much closer to its sun, or its ices were exposed to far more intense radiation. This is a wow factor, because it makes you wonder how many different types of cosmic environments exist out there, each producing unique objects that defy our current categorizations. The universe is not a monolithic structure, it's a kaleidoscope of possibilities. And 3I Atlas is a vivid example of this cosmic diversity. It means that searching for Earth-like planets might be too narrow a view. Perhaps we should be searching for 3I Atlas-like systems, which could harbor entirely different forms of life based on a different chemical foundation. The thing nobody tells you is that this isn't just about comets. It's about how we detect and characterize everything else. If an object as large and active as 3I Atlas can come from such a different environment, what about smaller, fainter objects? What about the next interstellar visitor? Will it too reveal an entirely new set of rules? This constant re-evaluation, while exciting, also means our models are perpetually catching up, making the universe feel less understood, more mysterious. And you can see this everywhere in science. New data always refines, and sometimes shatters, old paradigms. 3I Atlas is a paradigm shatterer. 3I Atlas has redefined our cosmic understanding. Could its strange chemistry hint at even stranger origins for life itself, spreading across the stars? Like and subscribe for more mind-bending space revelations.